Greetings, folks. We left you with the question, which is more concentrated, a 1.0 molar solution or a 1.0 molal solution? We said both of them contain 1 mole of solute. It was the solvent that was different. In a molar solution, it's 1 mole of solute per liter of solution, the total, and 1 molal, it's 1 mole of solute per 1 kilogram of solvent. So if you were to make them up, it would both contain the same amount of solute, 1 mole. The final volume for molar is 1 liter, but the final volume for molal will be greater than 1 liter because you're putting more particles into the same flask. So you've got more solvent over here. You've got a complete kilogram of water, a complete liter of water. You've got less than a liter of water over here. Molal, the little m, will be less concentrated. You're taking the same solute and dissolving it into more water. Molar will be more concentrated. You're taking the same solute and dissolving it into less water. If we ever test again, there's something like that. You have to think along those lines on there. Let's do a few questions based on molality. So let's start with something simple. Let's use our solute of sodium hydroxide. It's got a simple GFM, 40.0 grams per mole. If I take 20 grams of sodium hydroxide and dissolve it into 250 grams of water, what's the molality? Well, 20 grams of sodium hydroxide is half a mole. 250 grams of water is 1/4 of a kilogram. Put your moles over your kilograms, it's a 2 molal solution. What if I said, all right, a 1.50 molal solution of NaOH aqueous contains, I don't know, 400 grams of water. How many grams of NaOH are in it? Molality is moles of solute over kilograms of solvent. So moles of NaOH or kilograms of water. Here it is algebraically. It's a 1.5 molal solution. How many moles of NaOH do I have? Well, I don't know. We're ultimately looking for NaOH. How many kilograms of water do I have? Well, 400 grams. That's 0.400 kilograms of water. Cross multiply that out. X is 1.5 times 0.4. X is 0.6 moles of NaOH. Well, 0.6 moles of NaOH. 1 mole is 40 grams. That's 24.0 grams of NaOH. Now we could do that dimensionally. We could say 1.50 molal really means you've got 1.5 moles of NaOH per kilogram of water. Now that's complex. I always said recommend that you start with the simple. So 400 grams of water is the other piece of data. Let's start there. 400 grams of water. A 1,000 grams of water is a kilogram of water. We've got 1.5 moles of NaOH per kilogram of water. And a mole of NaOH is 40.0 grams. So here you go. Top times bottom divide. 400 divided by 1,000 times 1.5 times 40 and you still get a whopping 24.0 grams of NaOH. Once again, I don't care which way you work. I'm kind of wired to work algebraically with these types of problems, but I'm certainly well versed in the dimensional stuff and see its beauty as well. How you do it is up to you. I will take in pictures of the key for molality, worksheet 3. I think there are a dozen problems on there, and I will post that answer later tonight. All right, so that's your homework, worksheet 3, molality. Thanks much.